Okay, this is video 3 of the series Intro to Pro. And at this point, my map looks slightly different than yours. And I'd like you to go ahead and on your own clip your buffers to the SLHS zone, attendance zone. And if you don't quite remember how to do that, go back and watch video 2 again to refresh your memory on that. So now we're going to move forward and try another way to clip or isolate part of the population or the addresses, sorry. We're going to isolate the addresses that are inside the buffer. So let's pretend it's like, because of COVID, there's too much crowding on the buses. So those poor souls that live within 3/4 of a mile of school have to walk. And so we'll figure out what addresses we're going to be sending letters to tell them that buy some new walking shoes. All right. So, but there's always more than one way to do this in Pro. And clipping has always been my favorite because it's easy. It's a cookie cutter. But you can also do this by using selections by location. And I like this feature much better in Pro than in online. It's intuitive. Select by attributes means selecting things that have certain characteristics, easy to understand. Select by location is relative to other objects or being inside or outside of a buffer, let's say. That's a location. So it's just intuitive. All right, so let's try that. So we're gonna instead of clipping the addresses to the buffer like you just clipped the buffer to the boundary, we're gonna do it by location instead. So you click on select by location. The input features that you want to get clipped are the SLHS addresses, and we want to know whether or not they intersect. Okay, so we can choose things like intersect, are within a distance, are completely within, things like that. These are those queries that you're familiar with in ArcGIS Online, but they look different here. Okay, so we're going to say the SLHS addresses that are completely within the selecting feature, which is the buffer. And I called it, it's my buffer clip because I clipped it to the school boundary. And search distance, I'm not going to mess around with this. I'll leave that alone because I'm just going to leave that like this. It's a new selection and we can just apply that. Let's see what it does. Okay, hit OK. So you see that it highlighted all the addresses that are inside the buffer. And if we opened up the attribute table for the addresses, so everybody go over here on the left side and right click on SLHS addresses and open up the attribute table. It'll pop up at the bottom of the screen. You're going to notice that some are highlighted and some are not. And there's some clever sleight of hand you can do here. As I scroll through this, you can see some are highlighted and some aren't. Okay, so the ones that are highlighted are the ones that are in the buffer, and the ones that are not are obviously outside. And if I wanted to switch it to the ones that are outside, I can actually do that by clicking this button here called switch, and it will just boom, it'll select the ones that are outside or the ones that are inside. Bet you can't do that with online. Okay, so I'm just going to close this table, and the way you do that is you up here above where it says SLH addresses on that tab, I can close that, and now my table's gone, but I still have my selection, and I can right click. This is another one of those things that's great about Pro. You can just right click on the object on the layer that you're interested in, and everything you selected can now be exported as a new layer. None of this find new locations stuff. Be careful my language. All right, so data. Export features. South Lake's addresses, Intro to Pro, just going to go into the Intro to Pro projections database. The output name, let's call this feeder buffer addresses. Oops, let's put underscore in there. All right, there we go. And everything else looks good. And let's go to environments. I think we're good here. Just go to environments and let's go ahead and make sure that this is still in the current projection and okay it. And it may, there we go. And so we have them up here at the top. Let's turn off the addresses layer. First, it's probably a good idea to clear the selection. If you go up top here, you're going to see a button. It's called clear. I also have it over here. I made it a shortcut up at the top. I can show you how to, well, it's easy to do. When you right click on this, try this. It's a good idea to do this. Right click on that clear button and choose show in quick access toolbar. Okay, and then that will bring it up here. And then you'll have quick access to it all the time instead of only in the map view. There's many times when you're in other tabs that you're going to want to clear. And if you don't make this shortcut, you have to go back to the map tab to find it. That's terrible. Okay, so clear it, and now that you see your selection's gone, and you can turn off the addresses for this zone and they're gone, but notice that we still have the addresses for the feeder buffer. Okay, pretty cool. And so let's see what we're going to do next. Okay, so everything we've done so far with the trimming that we've been doing with clipping or selecting by location, that is only applied to vector data. And it's been a while since we've talked about the different types of data, but you should remember back from the beginning where I talked about three types there of vector data: points, lines, and polygons. And we have polygons here and we have points, and actually the buffers, although they look like circles, are just polygons with really small segments. So we can clip them relative to each other, and we've been doing that. But now we're going to work with elevation data, which is raster. And you don't use clipping, you use something else. It's called extracting by mask. So we're about to get started on that. Let's do that by turning off the feeder schools. I'm sorry, the feeder addresses. And we're going to turn off the schools, turn off South Lakes High School, and turn off the buffer, and just leave the South Lakes High School attendance boundary. And go into catalog, reopen catalog, and find FC elevation 30 meters and add this to the map. Right click, add it to the map. And this will take a while, and it might ask you, is this calculating statistics and all of that? You choose yes for that and let it load. Okay, there it is. And you can probably tell that there are some stream valleys here and things like that. Let's zoom out and just see what the extent of this is. Okay, there we are. This is a large data set, and the farther out you look at it, the clearer it looks. It's kind of like looking at a photograph, and if you zoom in too close on the photograph, it starts to look pixelated. Do you see that? Do you see the squares? Because it is like a photograph, except that these colors that you see are just representing different elevations. It's not really a black and white photo. Those are light colors mean higher elevation, and darker colors are the lowest elevation at sea level. Okay, that's Chesapeake Bay. So the colors here are symbolic for elevation. So let's try to get this shrunken down to just our area, and just our area of interest, which is South Lake's attendance zone. So here we go. Let's try that. Go up to analysis, click analysis up there, or you could bring it up over here. You could re-click on the toolbox, or if you have geoprocessing available over here on the right side, you can just clear out, right where it says find tools. I want you to type in extract by mask. Okay, and there it is. It's a spatial analyst tool that extracts the cells of a raster that correspond to the areas delineated by a mask. So in this case, the raster is the elevation data, and the South Lakes High School attendance zone is the mask, or the cookie cutter, however you want to look at it. All right, so we go ahead and click that. The input raster is the 30-foot elevation. Now it's important to, what does that 30-foot elevation mean? We're going to talk about that in a minute. Okay, and the input raster of the feature, or the, I'm sorry, input raster or feature mask data, we're going to use the South Lakes High School zone. And let's call this SLHS zone underscore again. So it's under SLHS underscore zone underscored ELEV 30. 30M. Okay, and let's see if this will run. Oh, first let's go up to the top and let's make sure that we get it to produce the output in the same coordinate system as the rest of the map, and now run it. And there you go. And you notice that it looks a little different shading wise, and the reason for that is the entire file here that we're looking at has a lot of variability from the highest elevations in light to the lowest elevations down here farther down the Chesapeake, or the river, I'm sorry. And so this that range is why all those colors are applied to that whole raster. But when you zoom in on South Lakes and you look at our elevation data set, the software is trying to do the same thing but to a smaller slice of data, so we see the colors shift. All right. Okay, so now let's return off the elevation 30 meter, and that's simply because it takes a while for it to render. And let's zoom in real close on maybe down here where we see this a lot of different cells. Yeah, this is great. Okay, so now I want you to go over to map, click up here at the top on map, and then go to measure, and we're going to measure a distance, and we're going to change this. Let me see, planar is what we want, yes, and we're going to use meters or metric. Yeah, we can just go down here and choose meters right there. Okay, and I want you to pick a square where you can see like the width of it, and click on it and go across it, and it says it is, it's 28 meters. Okay, let me see what it is from the top to bottom. About 27 meters. Okay, so it's not exactly 30 meters, but it's not really claiming, 30 meters is just an approximation. This is a 30 meter by 30 meter digital elevation model, and so it's, it's a square, a little bit bigger than a classroom. Okay, now we can close this down and zoom back out, and the last thing we're going to do here is change the symbology on this. So let's right click on it, choose symbology. This might work better than, yeah, this worked great. Okay, and then we're going to look for, let's go ahead and show the names, and now we're going to look for the one that says elevation 1. Let's see if we can find that. And when you find elevation 1, apply it, and you should get that. And that's where we're going to stop for this segment.